Hey guys, welcome back to Flipped. Before you get started on the video, I need you to make sure you have the notes I gave you in class today. You also need to know that the colorful equation paper that we did in class today is not due until Friday. I have changed the due date because a lot of people are struggling. Once you have the notes from today ready to take notes, I need you to press play and we can continue. So over the past few days, we've practiced solving equations with variables on both sides, only containing integers. And integers mean positive and negative numbers. What if we change some of these integers to fractions or decimals instead? So that's what we're doing today. We are going to solve equations with that involve fractions and decimals. So let's get started. In order to do this, you need to go ahead and skip the first slide or the second slide and go to the slide where you see the multiply by a common denominator. That tells you how to do it. To find a common denominator, multiply both denominators. All right, so if our equation is 2/3 x minus 7 equals 1/4 x plus 3. Multiply 3 times 4, so that equals 12. And what you're going to do is you are going to draw your line, like we do every single time, and you are going to multiply by 12 on this side and by 12 on that side. Because remember, whatever you do to one side, you have to do it to the other. So now you're going to distribute 12 times 2. You can put a 1 right there if you want to make it look like a fraction. 12 times 2 is 24 over 3x minus 12 times 7, negative 7 is negative 84. Equals, and we're going to do the same thing this way. 12 times 1 is 12 over 4x. And then 12 times 3 is plus 36. Now, it still looks like I have fractions, but if you look, these can be simplified or reduced. 24 divided by 3 is 8x minus 84 equals 12 divided by 4 is 3x plus 36. And now it should look like an equation that we know how to solve. We know that we want our variable to stay positive, so I am going to isolate my variable on one side. This is going to be my variable side, so I'm going to take the inverse or the opposite of this operation and do it to both sides. So I have 5x minus 84 equals 36. I know I need variables on this side, so I'm going to move my constant, and the opposite or inverse operation is positive 84. I'm also going to do it to both sides. So I have 5x equals 120. Divide both sides by 5 so I can have my x by itself, and you're going to get, 12 would be 2. 24. Do not let fractions or decimals scare you because, one, you have a calculator you're going to be able to use on STAR. I need you to know the steps, but on STAR, if they're just asking you to solve, you can use your calculator. You can also use your calculator now to check your answers. So let's go to our next example. Okay, let's talk about this. Is 12 the only common denominator that works to eliminate the fractions? Is there another common denominator we can use to eliminate? So let's talk about that. We tried 12. Could we try 24? We could, and it would work. So here we go. All right, so 24 times 2 is 48, divided by 3. 48 divided by 3 is 16. So I have 16x minus 24 times 7 is 168 equals, and I'm doing this in my head, but of course you have calculators. 24 times 1 is 24 divided by 4 is 6x. 24 times 3 is 72. I'm sorry, that should be plus 72. Again, now it looks like something we can solve. I want to isolate my variable, so minus 6x on both sides so it stays positive. So I'm left with 10x minus 168 equals 72. Plus 168 plus 168. You get 250, so, I'm sorry, you get 240. So 10x equals 240. Divide by 10, divide by 10, and x equals 24. And you will notice that your solution is the same thing as what we got on this slide. So it doesn't matter which common denominator you divide by, and the answer is no. Make sure you're pausing or rewinding if you need help answering these questions. All right, so here is another example. It's the 5th slide on the sheet. It says eliminate the fractions and solve. So I'm going to, I see there's fractions, so I'm putting everything in parentheses. 2 times 8 is going to be 16. All right, so 16 times 1 is 16 divided by 2 is 8x. 16 times 3 is plus 48 equals, and if you don't know that math, it's 16 times 1, 1 times 2, right? 16 divided by 2 is 8. And then 16 over 1, or just 16 times 3 is 48. I did it in my head, of course, but if you need to use a calculator, do not be afraid. And then 16 times 5 is 90 divided by 8. I'm sorry, it's not 90, it's 80 divided by 8. So 16 over 1 times 5 over 8 is 80 divided by 8. So that equals 10. So you're going to have 10x minus 16. And now it looks like a problem we know how to solve. I want to isolate my variable. Again, it does not matter which variable you move as long as you remember the rules. I like to move the variable where I know it's going to stay positive. So minus 8x minus 8x. And why did I do minus 8x? Because it's the opposite or inverse operation. I'm left with 48 equals 2x minus 16. Remember, my main goal is to isolate this variable. So opposite of negative 16 is a positive 16. Those cancel. I'm left with 2x here and 64 on this side. Divide by 2, so x equals 32. Again, I'll say make sure you're stopping the computer if you need to write down answers and I'm talking too fast. All right, so let's go ahead and move on to decimals. Now, what if we use rational numbers that included decimals? So here is our first problem. It's going to be slide 6 on the first side of your paper. And you're going to work it exactly like if you had whole numbers. You know your main goal is to isolate your variable, make it positive. So which variable am I going to want to move? I have a 3.5x here and a negative 5.9x there. I want to move this one because it will be positive. That cancels, and I have, remember your decimal rules, but you also have a calculator, 9.4x plus 0.7 equals 17.62. Remember, I want my decimal by itself, so I'm going to take the inverse of positive 0.7 and do negative 0.07. This decimal and this decimal are the same. I just added a 0 as a placeholder. So I have 9.4x equals Well, I even have to pull out my calculator. I don't want to do this one in my head. So 17.62 minus 0.7 equals 16.92. Divide by 9.4 and you get x equals 1.8. Now, you can use a calculator for this, but only for the computation of the adding, subtracting, multiplying, or dividing. You can use the calculator to check your answer, but I want you to show me the steps you did in order to get full credit on the problem. All right, last example is going to be 0.3x plus 0.76 equals 0.32 plus 0.52x. Draw your line. Look at your steps. Is there anything for distributive? No. Is there anything to combine like terms? Well, on this side, there's nothing. On this side, there's nothing. So I don't need to combine like terms. There are no fractions for me to get rid of, so I know that my next step is to put variables on one side and constants on the other. Now, I'm going to look at my two variables and determine which one I want to move. If I move the 0.3x, that means I'm going to subtract and subtract. 0.3 is less than 0.5, so it stays positive. But if I move this one, I would have a negative 0.5 with a positive 0.3, so it would be negative. That right there tells me I do not want to move my 0.5x. So here we go with solving this equation. Negative 0.3x. Negative 0.3x, because it's the opposite operation or the inverse. Those cancel. I'm left with 0.76 equals 0.32 plus 0.22x. My variable's on this side, so I know my variable needs to stay on this side. So in order to get rid of everything else besides the variable, I'm going to take the inverse or opposite of positive 0.32, and it's going to become a negative 0.32. If I do it to one side, I have to do it to the other. So I'm going to be left with 0.44 equals 0.22x. All right, to get x by itself, you're going to divide by that coefficient on both sides. Those cancel, and you're left with x equals 2. So, that is all for our notes. This problem right here where it says you need to solve in your ISN is going to actually be the problem you solve in your video survey. So make sure you do that and submit it before you come to class tomorrow. And we will take these notes and play an activity called Find Someone Who tomorrow in class. If you have any questions, make sure you email me or text message me, and I will get back to you as soon as I can. Have a great evening, guys.